Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. Am I properly audible and visible? Can you please confirm the same in the chat box? Yeah, hello everyone. We have 18 people with me right now. Okay, yeah. So can you please mention your names in the chat box, those who are present, and those who were present in the previous streaming as well of the SDE sheet? You must have seen me there. Hello, Akash. Yeah, so I have shared my screen as well. So just write a +1 in the chat box if you are able to see my screen. Yeah. So, okay, Kunal, you are the new one here. Yashwant Reddy, hello. And we have Samir Thavare. Okay, yeah. So, I welcome everyone present here. So, let us wait for 2 or 3 minutes more so that other people can join. And after that, we can begin with our series. So, before that, let me give you all my introduction. So, my name is Gaurav Kumar Shaw, and presently, right now, I'm in my third year of BTech, and I'm doing my BTech at Industrial and Systems Engineering at IIT Kharagpur. So let me give you a few information about the series. So this is a month-long series, and what I'm going to discuss in this is equal to is complete theory as well as the problem solving for graphs as well as tree, which are required for interviews point of view. Okay, so basically this series will be helpful for the students who are in their third year or in their final years. So who will be appearing for their upcoming internship and placement season. So I will be discussing the theories first, and then I will be discussing the common interview problems that are asked considering graphs as well as trees. Abhishek is asking, sir, graph complete पूरा पढ़ाएगा जाएगा? I won't be completing everything related to graph. I will be just covering the necessary important theory related to graphs, and then I will be discussing the problems. I will show you. I won't be teaching from very basic, and won't be covering entirely 100%. I assume that you would have gone through the concepts of graph previously, and this can be treated as a crash course kind of stuff. But this course can also be treated as a complete course if you are willing to do some extra work after the session gets over. Okay, so basically I will be going through the session in such a way that all the topics get covered, and after each topics get covered, you can just do your own revision of whatever things that you do not know already. In that way, basically you can cover all the topics. Okay, so let's come to the planning of the series. Okay, so let us see, we have 22 people with me. Sagar Prajapati, hello. Kunal Boxer, you are in your second year, very good. And I must say everyone that people who are in the second year, this is a perfect time to start with data structures and algorithm for your interview preparations, which will happen at the end of second year or the beginning of third year. Okay, so let's look into it. Hmm. So the plan of the series will be something like this. There will be a total of 15 lectures, and it will start from today, that is 5th of December, and it will continue till 5th of January 2023. So I will be coming live at 10 p.m. every alternate day. Okay, every alternate day. So basically, if I have come live today, that is on the 5th of December, I will again be coming live on 7th of December with a new topic. Okay. Now, after the class gets over, the lecture slides, that is, this lecture slides, the link will be given in the description. Okay, you can download the slides as a PDF form. Other than that, I will also be giving you homework problems. Okay, not necessarily that homeworks will be given after every videos, because for example, in the today's video, it's just an introduction about graphs and its various terminologies. So there are no need for any homework. So I won't be giving any homework today. But tomorrow, when I will be discussing about BFS and DFS, I will give you practice problems. So homework links will be given in the description as well. So you have to solve those. So if you're following my lectures, all you have to do is follow the lectures, and after you follow the lecture, you have to basically do a little bit of revision as well, and solve the homework as well. So if you're doing this too, you can get maximum output from the given session. Okay. So any more questions? Tejas is asking, what about third year? Basically, I was saying from that point of view is that students who are in the second year will basically get a chance to have their interviews in the beginning of third year. Okay. Handwriting. Tejas, I'm sorry about my handwriting. I will just improve it from the next slide onwards. Okay. So I hope everyone got whatever I was trying to say. Okay. So at 10 p.m. every alternate day, and I will be giving you lectures, and I will also be giving you homeworks. Follow my lectures, do the revision after the session gets end, and if there are certain important topics which you do not know about, and I have mentioned in the session, kindly go through those theory on your own. Okay, in case if you want to go very deeply in the concepts, solve those homeworks. Okay, and doing this for 1 month will be it will be enough for you all to uh, solve any problem related to graphs and trees which are asked in interviews. Okay, bro, watching recorded will be better. Yes, Kunal, if you feel like that watching recording will be better, in that case you can feel, but I will recommend you to watch the live streaming as well, because in live streaming there's a good amount of interaction that can happen. And what happens is that whenever you're watching something live, so the retention is much higher. Okay, so if you watch something at a 2x speed in a recorded version, the retention you will forget after a few days, but the retention will be higher if you're watching it in an interactive fashion, that is in the help of a live class. Okay, so I hope everyone got it. Which language are you using? Yes, Samir, that was a good question. So this entire series I will be using C++ language to solve. Okay, so the C++ language will be the primary language used to solve this question, while I'm teaching the concepts as well as to solve the questions. Okay, and I hope that many people here would be comfortable with Java or Python, but I would recommend everyone that C++ is a very powerful language considering data structures and algorithms. So therefore, I would request everyone to kindly learn C++. Okay, Java is also a very good language. Um, yeah. So any more questions or should we start? Yeah. So we have 23 people with me right now. 24. All I want you all to do is that the session on the okay. So like the YouTube session that is happening right now, and subscribe to the Geeks for Geeks practice channel, and we will be basically similar type of series will be again introduced in the future. In this series, I am covering graph, but my other mentors will other cover other parts of the topics as well. So you can expect a variety of content on this channel. So I would request everyone to kindly uh, subscribe it. Okay, so let us start then. Yeah. So I would want everyone to give me their uh, to undivided attention for the next 30 to 40 minutes, and I will be discussing majority of the concepts needed for graphs and trees. Okay. So for us first, let us look into the definition of graphs. Okay. So can anyone tell me what are graphs? Anyone? How long the session would be? Yeah, the session would be at max 1 hour. Like the session can be from anywhere to 50 to 70 minutes. Okay, on an average it will be around 1 hour. Okay, now it may happen that uh, Up to 11 or 12. How long the session would be? Up to 11. You can consider up to 11. Yeah. So it may happen that that if I had to take more number of concepts and the time is less, I may take an extra class, or the session getting may extended by 30 or 40 minutes. Okay, I hope that would be okay. But since today is the first session, I won't be extending it. Okay, so without wasting any more time, let us just start with the concepts. So tell me, what a graph? It is a data structure. It has nodes and edges. Devesh is saying, okay, non-linear data structure. It is a non-linear data structure having edges and vertices. Yeah, that's correct. Yeah, all the definition given in the chat box are correct. So first of all, graph is a data structure. Okay, and it is a non-linear data structure. Okay, now everyone knows what a linear data structure. Linear data structures are arrays. Arrays and vectors are linear data structure, and graphs are non-linear data structure. Okay, now yeah. So basically, now this non-linear data structure contains two important things, which are nodes and edges. Okay, so what I can say is that any combination of nodes and edges present will make a graph. Okay, for example, let's say I have got four nodes and these are connected something like this, or let's say this is a nodes, and there are five nodes and one, two, three, four edges, five nodes and four edges. So this makes a graph. Okay, now these nodes and edges can be in any fashion, in any way connected to each other. It doesn't matter. It will always make a graph. Okay, I hope everyone understood it. Okay, now we will be looking into collection of nodes and edges. Yeah, this is also a very good definition. Collection of nodes and edges. Now let us look into other types of graph. Yeah. So the first and the most important division that the graph can be is that the directed and the undirected graph. Okay, the directed graph and undirected graph. Hmm. Now, I just mentioned something called edges. Now, the presence of these edges will determine whether a graph is directed or a graph is undirected. So, let us say I have got two nodes. Okay, in the first instance, I have got an edge between the two nodes. So, let's say this node is 1 and this node is 2. So, if there are no arrow marks in this edge, it is called undirected graph. It means that 1 is directed to 2 and the 2 is also directed to 1. Okay, so it basically means 1 and 2 are connected in both ways. Okay, but if I draw something like this is node number 1, this is node number 2, and this is a directed edge between node 1 and 2. It means that 1 is connected to 2 in this fashion only, and 2 is not connected to 1. Okay, vice versa doesn't happen. So this is a directed graph, and this is an undirected graph. Okay, I hope everyone understood it. Any doubts here? Any doubts? Okay, bidirectional and unidirectional. Okay. Yeah, yeah, basically undirected graphs are bidirectional in nature, and undirected graphs are unidirectional in nature. And one more thing is that, let's say if I've got one node and two node, and if I represent something like this, a directed edge from 1 to 2 and another directed edge from 2 to 1. So this is also a directed graph, but it looks like an undirected graph because 1 is connected to 2 and 2 is also connected to 1 by a directed edge. Okay, so this is also an undirected this is also a directed graph, but it looks like an undirected graph. Okay, so this can also be represented. I hope everyone understood this special case. So let us look into other examples. Hmm. Hmm. Yeah, and one more thing is that whenever there are edges and nodes, so basically we represented by u and v. Okay, so this is just the variable names that I will be using later on. For example, if in case of undirected graph, u is connected to v and v is connected to u, but in case of directed graph, u is connected to v. Okay, so this is just a variable terminology that we will be using while we are writing our code. Okay, so this is done. Different types of graph, that is the directed and undirected graph. Now we will be going to other parts. So any doubts till now? Hmm. So Tejas is saying edges having direction is known as directed graph. Yes. So G of U and V. Okay. Now weighted graph. Okay. Santosh, I will be telling you about weighted graph, but a little later. Okay. Let's look into other concepts before we move there. Okay. So no doubts there. Okay. So let us look into another important thing here is that cycles. Okay, so tell me, what are cycles? Yeah, can anyone tell me what are cycles in a graph? Can anyone tell me what are cycles in a graph? Hmm. Yeah. So basically, what happens is that, let's say whenever we have a graph and we are standing on any given node. Now, if there exists a path, okay, a path from the given node such that after traversing that path, I again return back to my given node. Everyone got it? So there exists a path such that if I am standing on any given node and if I traverse that path, I will again return back to the given node. For example, let's say this is my node number 1, this is my node number 2, this is my node number 3, this is my node number 4, and the graph is connected something like this. So it means that 1 and 2 are connected by an undirected edge, 2 and 3 are also connected by an undirected edge, 3 and 4 are connected by an undirected edge, 4 and 1 are again connected by an undirected edge. So let's say if I start from 1, I can go to 2 because 1 is connected to 2. I can again go to 3 because 1 and 2 is connected to 3. I can go to 4 and again come to 1. So I started from 1 and I again came back to 1. So by following the path 1, 2, 3, 4, 1. So basically if I am following this path, I'm again returning back to 1. So it means that there is a cycle in this graph. There is a cycle in this graph. Okay, got it? When we start traversing from one point and we reached again on the same point, Devesh is saying, yes, Devesh, you are correct. To reach a point by touching all the points. To reach a point by touching all the points is not the perfect definition because there may be other points which are not a part of the cycle. Okay, so it may happen that there is a cycle in the graph, but we are not reaching all the points because it is not necessary. I just want to reach back to the point in which I am starting. It doesn't matter that I have to go through all the points. Okay, chalo. So let us look one more thing. Hmm. So this was a case for undirected graph, but let us look into a case of directed graph. So let's say 1, 2, and 3. So is this a cyclic graph? Can anyone say? And let's say another example, 1, 2, 3. Yeah. So this is example number 1 and this is example number 2. So can anyone say which one is cyclic and which one is not cyclic? Yeah. Devesh is saying example 2 is acyclic. Okay. Yeah. So, see, the thing was that in case of directed graph, the example 2 was also looking that some kind of circle was getting formed. But in case of directed graph, I just mentioned that if there is a directed edge, it means that I can go from in that direction only. So if 1 is connected to 2, I can go from 1 to 2 only, but I can not come back from 2 to 1. So similarly, 2 can be only go from 2, we can go only to 3. But now since 3 doesn't have any edge, which is going outside, so basically from 3 I cannot go to either 1 or 2. So I am just locked at 3. So therefore this path 1, then 2, then 3. So this is a valid path. But since I started from 1 and I'm not able to return back to 1, so this is not a cyclic path. So this is a directed graph, but it is an acyclic graph. Okay. But in this case, as you can see, I was coming from 1 to 2, then I can easily go from 2 to 3, and after that from 3 to 1 as well. So the path was looking something like this: 1 to 2, 2 to 3, and again back to 1. So basically, I was again started from 1 and ended to 1. So therefore, this is a cyclic graph. And this type of graph is called DAG, the graph which are acyclic in nature and they are directed. So directed is like acyclic graph. Okay, and there are various algorithms related to directed acyclic graph which we will study in the later sessions. Okay, I hope everyone understood these two concepts. Can I just have a +1 in the chat so that we can move ahead? Yeah, it is called directed acyclic graph. So a small homework that you all can do is that read more about directed acyclic graph. What are those? and come for the next session. But I will be covering more the concepts in the later session because right now those are not important. Okay, I hope everyone understood it. So now let's come to the next part of our learning, and in this part I will be telling you about, yeah. So let's talk about path. Okay. So what exactly are path in a graph? Can anyone tell me? Yeah. So what exactly are path in a graph? So this is not a conventional definition. It is just something I would like to mention to everyone before I move to the next part. Does anyone know what a path? Yeah. So basically, path is nothing but a series of nodes that you can traverse, a series of nodes that you can traverse. Okay. So what does this means is that let's say I have a graph and it looks something like this. Okay, so it looks something like this: 1, then 2, then 3, then 4, 4 again move to 2, 2 to move to 5, 5 to 6, then 6 again moves to 4, and again 4 to 7, 7 to 9. So I can draw a path something like this. Let's say I start from 1, I go to 2, I go to 3, I go to 4, I again go to 2. Okay, and I stop. So basically, this can be a path. I start from 1, then 2, then 3, then 4, and again come back to 2. Okay, so this can be a path. So path is nothing but basically a collection of nodes that you can traverse. Okay, and the it cannot be any connection but a valid connection only. Okay, it's not something like that I'm standing on 4th and then I'm going from directly to 6, because I cannot go to 6 from 4. I can only go to 2 from 4. If I want to go to 6, I have to go from to 2, then to 5, and then to 6. Okay, so if the question is asked that write a valid path that I can go from 1 to 6, so how will you do that? You can say that you can go to from 1 to 2, then you can go from 2 to 5, and then you can go since yeah, this is a directed graph, you can go from 5 to 6. You can say something like this, or you can say something like this: you can go from 1 to 2, 2 to 3, 3 to 4, 4 to 2, 2 to 5, and then 5 to 6. Okay, so basically whatever path you are writing, it should be valid. Okay, so this is just a small concept related to path. So never write an invalid path. Okay, connection between two vertices, Santosh is saying. Okay, yes. Yeah, connection between two vertices is correct, but one important word you are missing is that it should be a valid connection as well. Okay, so I just wanted to make you all know that related to this definition. So let's move to other important stuffs. Yeah. Yeah. So basically, we discussed about cycle, we discussed about path, and yeah, now we will be discussing about something called as the weights. Okay. So what exactly are edge weights? Hmm. So, since we discussed two types of graph, first was directed graph and the second was undirected graph. Okay. So, in both the cases, we had nodes and we had edges. Okay. So, nodes were a numbered value, let's say 1 and 2, and the edge was existing between them. So, this edge can be either directed or this edge can be either undirected. Now, the third thing that can happen here is that there can be a particular value associated with this edge called the weight of the edge. So, let's say I call this weight as WT. So, it means that, let's say, a particular weight has been assigned to this edge. So what are the significance of weight? So the significance of weight you can understand later in these sessions when we will be studying about algorithms like the Dijkstra's algorithm or the Bellman-Ford algorithm. Okay, so what happens, we uses the idea of weight. And you can imagine the weight as something like a toll task toll tax. So basically, whenever you're traversing a road, that let's say from 1 to 2, and you're using a bridge between 1 and 2, you have to give certain kind of tax, and that tax is basically the weight. Okay, so this can be an concept in which you can connect about the significance of weight. Okay, so the weights are basically useful to determine what exactly is the value of every position of the edge you're taking. Okay, so a small example I can write here. So let's say I have got 1, I have got 2, I have got 3, and I have got 4. Okay, so something like this. And let's say this is a undirected graph. This is an undirected graph. And let me write the edges weight. So the edge weight is 5, this is 6, this is 2, this is 1, and this is 4. Okay. Now I have been asked to go from node number 1 to node number 4 in such a way that the least possible weight has been traversed. Okay. So how will you do this? So this is the significance of weight. Yeah, weight can also be consisting of cost also. This can be thought of something as a cost. Okay, the wish. Yeah. So let's see. So if I am traversing from 1 to 4 via this path, directly from 1 to 4, I see that my cost is 6 because the weight is 6. Okay, so if I'm traversing from 1, then 3, then to 4, my cost will be something again 6, 4 plus 2 equal to 6. Okay, now if I'm traversing from 1 to 1, then 2, and then 4, my cost is again 6. Okay, so as you can see that whatever path I'm taking, all three are same. But let's say I change this path and I make this 2. Okay, so if I am traversing third path from 1 to 2 and then 2 to 4, the value would be 3. Okay, so as you can see that this is the least of all the values. So basically in that case, I will be taking this path because the cost is minimum. Okay, I hope everyone understood it. Can I have a +1 in the chat so that I can move ahead with the concepts now? Hello Devesh, hello Santosh. Okay Devesh. Are everyone with me? Those who started the session? I would request everyone, those who are starting the session, to kindly complete it. Okay, because if you put up a habit of attending live session every alternate day, so this will also make sure that you are practicing the questions that I'm giving in also a very consistent fashion, and this will help you prepare for your interviews in a much more planned way. Okay, and this will basically turn out to be fruitful as well. Okay, so let's move to the next part. Yeah. So we discussed about the definition, the terminologies. Now we will be discussing about representations. Okay. So everyone was saying that graph was a data structure, right? That graph was nothing but a data structure. So if it is a data structure, we should be able to represent in the form of a code, right? So we were just drawing some random stuffs like 1, 2, 3, 4, and there were a bunch of nodes, a bunch of edges. So how exactly am I going to represent this thing in the form of a code in any valid language, let's say C++ or Java? How are we going to do it? Okay. So does anyone know what are the methods of representing a graph data structure? Yeah. So Devesh is saying adjacency matrix and adjacency list. Yes. Hmm. Yeah, so there are basically two two ways in which you can represent graphs. The first is the adjacency matrix, and the second is the adjacency list. Okay, I will be discussing both of the ways how can you represent. I will also be discussing the code as well, and I will also be telling you which one of these two is better. Okay, so is there anyone who knows which one of these two is better and the reason as well? Anyone write in the chat box? If you do not know, I will be discussing it. But if you know, just mention it. Let me see which one is better and why. Okay, Devesh is saying adjacency list is better, but why? So is there Devesh who is only listening to me? List insertion and deletion are simple. Okay, yeah, these are the advantages and disadvantages. Okay, Yashwant, you are correct. Hmm. So as Devesh was saying, adjacency list is better. So one simple reason it can be that the space complexity in case of list is much better than in case of matrix. I will be telling you why. Okay. So let's say adjacency matrix. So first is that since graph is a data structure, it must have an input. Okay. So I said that I have got nodes and I have got edges. So how are we going to represent these nodes and edges in the form of an input and an output? Okay. How exactly are we going to do it? Okay. So let's say n is the number of nodes. Okay. Number of nodes, and m is the number of edges. So number of edges which are connecting these n nodes. So it may happen that these number of edges are not connecting all the nodes. For example, let's say I've got three nodes, 1, 2, 3, but only one edge between 1 and 2. So 3 is not connected with either 1 or 2, but that's okay. 3 is also a part of the graph. But in this node, it is an isolated node, not connected to any one of these two. Okay, I hope everyone understood the concept that if any particular node, it is not necessary that a node has to be connected to any other node of the graph. If it is not connected, it is also a part of the graph. Okay. I hope everyone understood this. So basically, we have n and we have m. So n is the number of nodes and m is the number of edges. So the first line of input will contain n and m. Okay. So which will denote the number of nodes and the number of edges. After that, I will have n m lines. So this m lines will basically describe the type of edge. For example, if something is written like this 1 2, it means that there exists a edge between node number 1 and node number 2. Okay, so since this is an undirected edge, I will consider that 1 is connected to 2 and 2 is also connected to 1. So I will fill my data structure in such a fashion. So let's say again I said 3 and 4, it means that 3 and 4 are connected. Okay. So let's say I've got 4 nodes, 1 2 3 and 4. 1 and 2 are connected and 3 and 4 are connected. Okay, so number of edges are 2. So this is a graph by the input of like this. Okay, so in order to represent this graph, the input will look something like this. I will have 4 nodes and I will have 2 edges, and the first is 1 2 and the second is 3 4. So this input represents this graph. I hope everyone understood it, how we are taking the input. Okay, because it's space consuming. Okay, so did everyone understood it, the concept of how I took the input? Yeah. So let us move ahead again. Yeah. So now input is done. Okay. The user has given us the input. Now our task is to store this input. Okay. So now in order to store this input, now we have discussed yeah, kindly excuse me for a minute. Yeah. So we already have the input. Now we need to store the input. Now I just mentioned that there are two ways to store the input. The first one was adjacency matrix and the second was adjacency list. Now I will be discussing the matrix part. So what exactly is a matrix? Okay. So a matrix is basically something like this, let's say. Now this matrix will contain n into n. Okay. So what does this mean? It means that let's say I have got n nodes. So the first will be 0, 1, 2, 3, 4, 5. Okay. This will be 0, 1, 2, 3, 4, 5. Let's say if n is equal to 5. Okay. So this is a matrix of 6 cross 6. Okay, why 6 cross 6? Because matrix will start from 0 based indexing and my nodes will start from 1 based indexing. Okay, I am assuming that my nodes start from 1 based indexing, and that is why I have declared a matrix called ADG of 6 cross 6. That is, ADG will be declared of size n plus 1. Okay, so this is the declaration of the matrix. Now what exactly are we going to do? So whenever we are reading the m lines which describes the edges, let's say the edge number 1 and 2. Okay, so 1 is connected to 2 and 2 is connected to 1. So in that case, what will I do? I will go to cell 1 comma 2 and I will put a number 1. I will go to cell 2 comma 1 and put a number 1 here. Understood? So if 1 and 2 is an input edge, it means that 1 is connected to 2 and 2 is connected to 1. So what will I do? I will go to adjacency matrix 1 comma 2. I will put a value 1 and I will go to adjacency matrix 2 comma 1, and I will also put up my value 1. It means that 1 is connected to 2 and 2 is also connected to 1. Okay, so similarly I will fill up all the values which are present. So let's say this is, the next input was 3 comma 4, so I will put 3 comma 4 here and 4 comma 3 here. Okay, so something like this can be done. And after I have filled up with all the values 1, and the remaining values will be filled up with 0. 0 denotes that no particular edge exists between that two nodes, and 1 denotes that there exists a node between the two there exists a edge between the two nodes. Okay, so 1 represent that there exists a edge, and 0 represent there do not no edge. Okay, so all I have to do is that basically declare a matrix. Yeah, so declare a matrix adjacency of n plus 1 cross n plus 1, and just put up all the values while I'm reading the m edges. So if 1 is connected to 2, it means that I have to put adjacency of 1 comma 2 as 1, as well as 2 comma 1 as 1. Okay, so and after I fill up all the m values, I will just put 0 to the remaining boxes, because it means that there are no edges connecting those two nodes. Okay, I hope everyone understood it. The adjacency matrix representation. Any doubts here? Is it a connected component? Connected component. Devesh was asking connected components. Yeah. So what I was saying is that it may happen that any particular node is isolated from the remaining other nodes. So in that case, also we have to include that node in our graph as well. For example, in this case, as you can see, this was a connected component and this was not a connected component. But overall, the whole both of these two things are making my graph. Okay. So there are various components in a graph. Some may be connected, some may not be connected, but altogether we have to consider it as a graph. Okay, while we are dealing with problems, and let's say you are solving a problem, and in that problem an input graph is given. So you are not supposed to just consider it that all the components will be connected, or all will be so basically you have to take the case that it may happen that they are not connected, some may be isolated as well. Okay, so you have to consider that possibility also, until and unless it is specifically mentioned that all are connected to each other. Okay, any more doubts? Yeah. So now is the part about discussing the adjacency list, concept of adjacency list. Excuse me. Yeah. Any more doubts? So can I have a +1 in the chat of those who are listening to me and have understood all the terminologies and the adjacency matrix representation? Hello Ankit. Hello Santosh. Hello Yashwant. Hello Devesh. Hello Yashwant. That's great. Yeah. Thank you, Abhinav. Yeah, so let us move to the next part. So we discussed the concept of adjacency matrix. Now we'll be discussing the concept of adjacency list. Okay. Now, in the matrix part, we saw that we were declaring a matrix of size n plus 1 into n plus 1. Okay. So, as you, yeah, it was evident from the fact here is that there were many unused boxes in the matrix, which means that there are no nodes connected to, no edges connected between the two nodes. Okay. So, how can we utilize the fact that let's not waste spaces? Okay. So, in that case, we will be coming to the concept of adjacency list, and we will be utilizing the concept of vector. Okay. So, we will declare a data structure of something like this: vector int adjacency of n plus 1. Okay, so what is this? Can anyone tell me what exactly is this line? First, I'm declaring a vector of type int, and the name of the vector is adjacency, and again I am writing something like as n plus 1 in third bracket. So what exactly is this statement? Can anyone tell me? So this basically is nothing but a vector. This basically is a vector of arrays. Okay, What is this? This is a vector of arrays. So this is the array part and this is the vector part, and it looks something like this. So let's say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Now this is a vector of arrays. So this vector of 0 part contains an array. Okay. So now what we will do here is that we will store the value something like this by doing pushback. Okay. So basically it means that, yeah. So adjacency of 0 is a vector, and I can push back certain values to this stream. So whatever nodes that are connected with 0, I will push it here. So let's say if from the 0th node, if node number 1, node number 2 and node number 3 are connected, I will just put node number 1, 2 and 3 here. And at the same time, I will put node number 3 as 0, node number 2 as 0, 1 as 0 as well. Because if 0 is connected to 1 and 0 is connected to 2 and 0 is connected to 3, it means that U is connected to V as well as V is connected to U in case of undirected graph. Okay, so this is just the concept of adjacency list. Okay, any doubts here? Adjacency vector having n plus 1 size. Yes, Devesh? Yeah. Okay, so let us look into an example to solve the properly understood the adjacency list part. So I am drawing a graph and I will be representing in the form of a vector as well. Okay. So let's say 1, 2, 3, 4, 5. Okay. This is a graph. How many nodes are there? N is equal to 5. How many edges are there? 1, 2, 3, 4, 5, 6. E is equal to 5 or M is equal to 5. Let me say M is equal to 5. Sorry, this will be 6. Okay. So there are 5 nodes and 6 edges. So now what will be the values? 1 is connected to 2, 2 is connected to 5, 5 is connected to 4, 4 is connected to 2, 4 is connected to 3, 3 is connected to 1. Any more? No. Yeah. So there are 6 edges, right? Okay. So there are 5 nodes and 6 edges, and I have to represent this in the form of an adjacency list. So first I will be declaring a vector int of type, let's say 5 plus 1, 6. Okay, n plus 1. So it means that I will be having 0, 1, 2, 3, 4, 5 and 6. Okay. Now in the case of 0, I won't be having anything because this is a 1 based indexing. But in the case of 1, I will be having 2 and 3. Okay. So let me write with a different color. So 1 may 2 or 3 hoga, right? Because 1 is connected to 2 and 1 is connected to 3. Now 2 is again connected to 1 and 4. 1 and 4 as well as 5. Okay. Now 3 is again connected to 1 and 4. Okay. And finally 4 is connected to 3, 2 and 5. Okay. So this is my adjacency list representation. And how are we going to fill it? Whenever we are reading the m values, or what we are going to do here is that this is u and this is v. So what we will do here is that adjacency of u dot pushback v and adjacency of v dot pushback u. So we will write these two statements, and after we write these two statements for all the m values, our adjacency list will be generated. I hope everyone understood it. Any more doubts? Uh, Hello, Shri Ganesha. I will request you to kindly ask doubts related to the content we are discussing right now and not something other than that. Hello, Devesh. So we have already discussed the adjacency list part as well as the yeah, the adjacency matrix part. So now how are we going to deal in case weight is given? Yeah. So can anyone tell me how are we going to deal with the same concept of adjacency list and adjacency matrix in case the weight of the graph is given? Because when we were writing about adjacency list, let's say in case of list, we were only including those value of the nodes which are connected to the node number 1. So one was connected to 2 and 3, and there was no way we are maintaining track of the weights. And the same time, when we were discussing about the adjacency matrix, we were just putting ones and zeros. So if it was connected, we were putting 1, and if it was not connected, we were putting 0. So how can we include the concept of weight in these two examples? Can anyone tell me? Kindly ignore my background noise. So let's look into it. Can anyone tell me, Devesh, Ravi, vector of vector, vector of vector? Okay, think more. I won't be needing vector of vector because basically, since I only have to store one particular value, so instead of a vector, let me just have a pair only. Okay, so that can be a possibility. But before I discuss about the list, let me discuss about matrix first. Okay, so in the case of a matrix, what have we do? What were we doing? We were putting one in case the nodes were connected. Nodes were connected. Okay, so there was an edge between the nodes, and we were putting 0 if no edge. Right. So instead of putting 1 and 0, let me put the weight. Instead of putting 1, let me put weight. So if there is a node u and v and they're connected to each other with a weight wt. So in that case, what will I do? I will put adjacency of u v as a wt, and at the same time adjacency of v u as wt. Okay. So if it is a non-zero value, so if at any value is non-zero, it means that there exists a edge. Yes, that is a clarity we can get, and the value present will be the weight of the edge. So basically, what we did, we just yeah, we just put the value of the weight in the I comma j cell. Okay, so basically, what happened here is that if I am going to any particular cell of the matrix and I see a non-zero value present there, it means that particular value is the value of the weight between the edge connecting the two values, the two nodes. Okay, so just by writing weight instead of just writing one, we just dealt with the fact of weight in case of adjacency matrix. Now, what about list? So Devesh just mentioned while he was saying vector of vector, I mentioned we can use a pair. So instead of vector of int, we will use a pair of int comma int. Okay, and the same thing, adjacency of n plus 1. Okay, so writing this statement, what does this mean? Okay, it means that let's say I have 0, 1, 2, 3, 4, 5, 6. So all these are vectors now. Okay, now instead I was initially what was I was pushing? I was pushing the value of the node in which one was connected, but now I will be pushing the value of the node as well as the weight because it is a pair, so I can store two values. So let's say one was connected to 2, 1, 2, 3, 4, 5. Let's look into this example only. So one is connected to 2 and one is connected to 3. Okay, so I will push 1 and I will again push 3 as well. But the weight of this is equal to, let's say, weight 1 and this is weight 2. So I will push 1 comma weight 1 as a pair and 3 comma weight 2 as a pair. Okay, so this is how things will be done. Okay, because I have declared in the form of a pair. So apart from writing the value of the node, I can also put the value of the weight as well. That is connection between 1 and so one is connected to 2 and one is connected to 3 with weight W1 and one is connected to 3 with weight W2. And at the same time, I also need to put up the value present in 2 as well. So 2 is connected to 1 as well with weight W1. Okay, similarly like this. Okay. So writing this in this way, my adjacency list is prepared. Okay, so any doubts here? Two more concepts are left. I can just quickly cover this. But if you want to store the u and v and weight, then we will use a vector. For u and v, we can use pair, but we want to store u, v, and weight. Okay, you are saying that you want to store u, v, and weight. Why will you store three values? See, the entire concept of using adjacency list was that, uh, yeah. So this was the array number. Okay, 0, 1, 2, 3, 4, 5, 6. Now these are the number of nodes. That is why I have declared an array of size n plus 1. And each this array is basically a vector. So I can say adjacency of 1 is nothing but a vector. And in this vector, I will store all those nodes with their weights which are connected to node number 1. Similarly, in the second part, I will store all those nodes with their weight which are connected to node number 2. Similarly, for node number 3, 4, 5, and 6, and so on. This was the concept of using adjacency list. Okay, and since we only have to store two values, the number of the node and the weight of the node, so that is the reason we are using pair. I hope you got it. Yeah. Now, the thing that I would like to discuss now, what exactly would be the case if we had a directed graph? In the question, it was mentioned that it's a directed graph, and if in the input is mentioned that 1 is connected to 2, it means that 1 is connected to 2 only and not vice versa. So, what modification can be done to this thing? Can anyone tell me? Yeah. So, basically, what can we do here is that, yeah. So, whenever we were writing adjacency of u dot pushback v. Okay. So, and again we were writing adjacency of v pushback u. So I will not write the second statement because u is connected to v and v is not connected to u. So this is wrong. So the second statement basically meant that v was also connected to u, but since it's a directed graph, I will just avoid writing the second line of code, and this line of code will only work. Okay, that adjacency of v dot pushback u or u dot pushback v. Okay, any one of them. So this is the thing. And also in case of the matrix, what we will do, if let's say I got two values, let's say u and v, and u is connected to v, so 1 is connected to 2. So while putting that, I will just write this statement and I will not write this statement. Okay, so I hope everyone understood. This is a simple concept. Yeah. Yeah, we will not write a second statement. Thank you, Devesh, for being with me till the end. Any more doubts here? We have 14 people with me right now, and we have successfully reached the last part of the ending of this today's first session. So, so let me do a recapitulate all the points that we discussed. So initially we started by uh, initially I told you about what exactly is how exactly are we going to proceed in the series. So the students who have joined late, let me tell you once again, we are going to do a 1 month long series. It will consist of 15 lectures on an average of 1 hour each. I will be coming live daily at 10 p.m. every alternate day. Okay, so from 5th December, it will start, that is today, and it will end till 5th January. I will, and this entire series is focused mostly on interview point of view. So I will be discussing necessary theories, and at the same time, I will be solving few problems. And I will also be giving you few homeworks as well. So since today was the introductory class, I just discussed some important definitions and certain important concepts. But from tomorrow onwards, I will directly jump to algorithms and I will look into problems. Okay. So I would request everyone to learn tomorrow. So that is the reason I have put alternate days, so you can get sufficient time to learn at the same time. Yeah. So after that, we discussed about two important stuff. That was the definition of graph and the two types of graph, that are the directed graph and the undirected graph. Later, we saw what exactly are cycles in a graph. We also discussed about what exactly is a path, and we just and I told you that a path is only a path as long as it is a valid sequence of nodes that we can actually traverse. Later, we got to know about the edge weights also and how it can be related as a cost. Hmm. After that, we also looked into the representation of the graph data structure. So there were two types of representation. The first was the adjacency matrix representation, and the second was the adjacency list representation. In case of adjacency matrix, we were declaring a matrix of size n plus 1 cross n plus 1, and this was taking more space of the space was taking of O of edges square. Okay, but in case of adjacency list, the space was much better. So the space complexity was better because we were avoiding the unwanted unused spaces. Okay. So in case of adjacency list, we were declaring vector of int and adjacency of n plus 1. So this is basically n plus 1 vectors and each of n plus 1 arrays, and each of these arrays is nothing but a vector. Okay. So this is basically an array of vectors, we can say. Okay. And after that, we also looked into the concept of what will happen if it is a directed graph and what will happen if it is an undirected graph. And again, we looked into the concept of what will happen and how can we modify their both representation in case the weights are also given. Okay. So we got to know that in case if weights are given, we will just replace the value of the weight instead of 1 in case of matrix. And in case of a list, we will declare in the form of a pair. So while pushing the value of the node, we will also push the value of the nodes as well as the weight in the form of a pair. Okay, so this was done. Yeah. So I hope everyone understood whatever we have discussed. Yeah, so Devesh is asking that how many questions are we going to solve till 5th of Jan? So basically, what will I do after discussing, let's say in the next class, I will be telling you about DFS and BFS, and we'll discuss two problems maybe in the live session, one of BFS and one of DFS, and maybe one extra problem. And I will give three homework problems as well. Okay. So basically, you can basically mostly do 50 to 60 problem easily in the 15 sessions. Okay, and you can if you want, I can give you extra problems as well, but those 50 to 60 problems will be the most important problem that can be asked in an interview point of view. Okay, so kindly be with me, and thank you Devesh for being with me till the end. Thank you Yashwant as well. And how many people are uh, yeah, so I would request you all to basically write to mark your attendance by writing in the chat box, and like and subscribe the channel as well. Okay, and meanwhile, you can check out Geeks for Geeks. There are various courses available on the Geeks for Geeks platform. There is a most famous self-paced course which you can basically buy, and that course is extremely good if you are learning data structures and algorithms. Okay, and it is available at an affordable price as well. You can check that out. The link is in the description. And after the session gets over, I will upload the graph, the slides link in the description as well. Okay, so any more doubts? So let's wrap up this session then. Thank you, everyone. Yeah. So good night. Let's meet day after tomorrow. That is on 7th. Bye bye.